called continuous functions. In fact, most of your important theorems include a prerequisite that any function in question must be continuous before you could even think about applying the theorem. For example, the intermediate value theorem, which we'll also learn in this chapter, requires that the function be continuous. Well, in theory, continuous functions are predictable functions. They have no undefined points, no breaks, no holes, no jumps in the graph. But enough talk. Let's take a look at some pretty pictures. Now this function f is continuous, but these, g, h, and I, they're not continuous. Each of them, in fact, is discontinuous for a different reason at the x value of x equals c. See, now this one, on g, you've got a little hole in the graph. That's called point discontinuity. Over here, on h, you've got a vertical asymptote that breaks the graph. Now this is called infinite discontinuity. And finally, here on graph I, you've got a graph that just plain snaps in the middle. And that's called jump discontinuity. Now, how can you judge just by looking at the graph of a function if it's continuous or not? Well, a continuous function makes a good bridge. Now see, if I drive across the graph of f, it holds up nicely. Whereas if I try to drive across the graphs of the other functions, I might fall through or fall off. So, continuous functions are predictable. But what does that mean? Well, it means two big things. One, no breaks. Well, we already know that breaks occur in functions when no limit exists there. Therefore, for a function to be continuous, it must have a limit at every x in its domain. Secondly, no holes. Continuous functions must be defined everywhere in their domain. Mathematically now, we say that continuous functions have this property. For every x equals c in their domain, the limit as x approaches c of f of x is equal to f of c. In other words, not only does the limit exist at every point, but the height the function reaches for every x matches the limit. How can you tell if this happens? It seems pretty complicated. It's actually easy. If you can evaluate any limit on f of x using only the substitution method, then the function is continuous. And that's all there is to it.